Hi there, grade 8, and welcome to WorksheetCloud Mathematics. Let's have a look what we're going to do today. We're going to look more at algebraic equations and expressions, and today we are going to look at how to work with exponents. This can be a bit confusing, so I'm going to go quite slowly, and please don't forget to email any of your queries to grade8@worksheetcloud.com, and somebody will get back to you with an answer. Right. We're going to look at this exponent. So here we've got 3 to the power of 2. We've all seen that before. You've probably been working with exponents from grade 5 or grade 6. But 3 is now known as the base and 2 is known as the exponent. Okay, what does that mean? It means 3 to the power of 2 is equal to 3 times 3. If you have a look at the exponent, it means how many times your base is multiplied to itself. So this time it's twice 3 times 3. Okay, let's now take that 3 and change it to an x. Okay, we're now going to replace the 3 with an x. It's no big deal. All we're doing is replacing a constant with a variable. Okay, we've got x squared this time. We've got the base as being x and the 2 as being the exponent. Right? What does that mean? It means x is multiplied by itself twice, x times x. There we go, 1 and 2, because our exponent is a 2. Okay, the exponent, remember, tells us how many times the base is multiplied to itself, or multiplied by itself. Okay, let's try expanding these. Like we had x squared is equal to x times x. See if you can pull these apart and expand these. I'm going to give you a little bit of time, so pause the video, try and work those out on your own, and then we'll go over them together. Right, x to the power of 3. Remember the power or the exponent tells us how many times we multiply the base by itself, and here we've got y times y times y. It's 3 times. A to the power of 4, a times a times a times a. There are 4 a's there, so it's a to the power of 4 expanded. The next one, we should have 6 b's because our exponent is 6, and it tells us how many times we must multiply our base together. 1, 2, 3, 4, 5, 6. Next one, z to the power of 7. We should have 7 z's because the exponent is 7, and that tells us how many times we must multiply z. Please make sure that you don't write an addition sign between your bases, because that would then mean that the 7 would go here as a coefficient, and it would be 7z if we went z, etc. So because it is an exponent, we have to multiply together. Right. Let's look at this a little bit further and make our base a little bit more involved. We've got 2x to the power of 3, 2x times 2x times 2x. If we have a look here, our 2x is our base, and it's made up of a coefficient and a variable, and our exponent is 3. Therefore, if we go back here, we can say that the base is 2x, and we are multiplying 2x by itself 3 times. 2x times 2x times 2x. Right. Now, if we had to say 2x cubed, it's different. It means something different. It now means 2 times x times x times x. That 3 is not affecting the 2 at all. Okay? It's only affecting the x. So in this case, the base is only x. The exponent is still 3. And the coefficient is 2. And the coefficient is not part of the base, not like in the previous example. So please be careful. If that was in a bracket, yes, the whole thing would be the base, and the exponent would be dealing with the whole thing. But here, the 2 is not in the bracket, so x is affected by the exponent and not the 2. Right. Let's try and expand these now. 3y squared minus 5a in brackets cubed, and 4x plus minus 2y squared. That went a bit quickly. Right, so now here we have 3y squared. It's 3 times y times y can you see that the exponent is only applicable to the y? It's only affecting the y because that is the base. The 3 in this case is only the coefficient. It's not part of the base. Right, let's look at the next one. We've now got the coefficient being part of the base because the brackets are there, and it's minus 5a times minus 5a times minus 5a. Can you see it's 3 times because the exponent is 3. In the third one, let's have a look at this. It looks a little bit more hectic. 4x to the power of 4 is 4 times x times x times x times x, and we are adding it to that whole base squared. So it would be minus 2u plus minus times minus 2u. Sorry, getting a bit tongue-tied here. Let's go over this one again. 4 times x times x times x times x, because it's x to the power of 4, and that 4 stays as is. Here we are multiplying the whole base by itself, so it's minus 2u times minus 2u. Right, let's try to apply this information to an expression. Right, let's have a look at the expression. 2x cubed plus minus 3x, all in brackets, squared. Okay, so let's see how we're going to do here. We're going to go 2x cubed, that remains as is because the cube is only affecting the x. Whereas in the second part of the expression, minus 3x is the whole base, so that you have to square. You have to put it to the power of 2. So I've just put the square brackets here just to make sure that it's differentiated from the other part of the expression. Minus 3x times minus 3x is minus times a minus is going to be a positive. 3 times 3 is 9, and x times x is x squared. So we would write it like that. 2x to the power of 3 plus 9x to the power of 2. Now just a thing to notice, when you have a positive, an even number as an exponent, and you've got a minus here, generally your minus goes away because minus times a minus is a positive. When your expression, however, not your expression, sorry, I'm really getting confused here. When your exponent is an odd number, that minus will stay there because a minus times a minus times a minus gives you a minus. Okay, you'll see what I mean just now. Right, so we've now got 2x cubed plus 9x squared, and we can write it like that. We can't simplify this expression anymore because we do not have like terms. These two are unlike terms. Remember in a previous lesson, when you've got unlike terms, you cannot do anything more with them. Right, let's look at the next one. 3x squared minus 3x to the power of 2. Here the minus is in between your two terms. The whole thing here is being affected by this exponent. So the whole thing is the base here. Just like the whole thing here was the base. The whole thing here was the base. This time though, the minus is outside the brackets. So that is actually your operation sign. 3x squared is equal or minus 3x times 3x, because then you're applying your exponent to the base here, and that's going to give you minus 9x squared, because 3x times 3x is 9x squared. The minus is between the two terms, so we keep that there. It had nothing to do with being squared. It was not inside the brackets. Right. 3x squared minus 9x squared, we can simplify further because they are like terms. Can you see? X squared minus x squared. And so we have minus 6x squared. Right? Does everybody understand? Let's go over it again. There's a minus, it is outside the bracket. So that square, that power doesn't affect it. That power is only to do with what is inside the bracket. So it's 3x times 3x. 3x times 3x is 9x squared. The minus is still there. They are like terms. We can simplify further. Minus 3x squared, 3x squared minus 9x squared gives me minus 6x squared. Right. Here's some for you to try on your own, and then we'll go over them. Think very carefully about them, write them down, pause the video, write them down, work them out, and then we can go over them together. Right, let's go over what you did. We've got a minus 2x in brackets, all squared, plus 4x squared. We're going minus 2x times minus 2x because the minus 2x was squared. Remember what we said just now? When your exponent is an even number, the minus times the minus is going to be a positive. The 4x squared we can leave on its own because that exponent is only affecting that x. Right, let's go on. We've now got 4x squared because minus 2x times minus 2 is going to give me 4x squared. Minus times minus is positive. 2 times 2 is 4. X times x is x squared. Have a look. Our terms are like terms. We can then simplify that further to 8x squared. Let's look at number 2. We've got a minus 3a to the power of 2. Here, the exponent is only affecting that a. It does not have anything to do with the minus 3. Here, we have minus 5a all in brackets, so that cube is affecting the whole thing there. That whole thing is the base. So let's see what we do. We've got minus 3a squared plus minus 5a times minus 5a times minus 5a. So we're going to, first of all, we know that this is an odd number. The exponent here is an odd number. So we're going to end up with a minus. 5 times 5 times 5 is 125. A times a times a is a cubed. And we're going to say minus 3a squared plus minus 125a cubed. We then are going to write it as minus 3a squared minus 125a cubed. Nothing can be done. It stays as is because they are unlike terms. Right, number 3, b to the power of 5 can stay as it is times minus 2b all squared. So here we have an even exponent. Probably means that our minus is going to fall away, our negative is going to fall away. B to the power of 5 stays as is. As I said, in brackets we can write minus 2b times minus 2b because we've now expanded that out. Minus times a minus is a positive. 2 times 2 is 4, and b times b would be b squared. So there we go. B to the power of 5 times 4b to the power of 2. Now this is a multiplication, so this changes things. If that was an addition sign, those are unlike terms. But it's not, it's multiplication. So we can expand that by going b times b times b times b times b, which is that part of it, times 4 times b times b. So when we've got multiplication, what we need to do is then add up how many b's we've got. So we would have 1, 2, 3, 4, 5, 6, 7 b's times 4. So it's 4b to the power of 7. Remember, that's what an exponent is. It's how many times the term has been, or the variable has been multiplied by itself, or the expression has been multiplied by itself. In this case, it is b's that have been multiplied by themselves 7 times and times by 4. So it's 4b to the 7. Right, here's another one. 8 minus a in brackets to the power of 2 times minus 3a squared. Okay, this squared only affects the a, remember. It does not affect the minus 3, whereas here minus a is affected by the 2. Remember, that's an even number, so that is going to disappear. So let's have a look. It would be a to the power 8a to the power 2 times minus 3a squared. And again, we can break it down because it is a multiplier. So we're going to go 8 times a, that's our first term, times minus 3 times a times a. How many a's do we have? 1, 2, 3, 4. So that would give us a to the power of 4. And 8 times by minus 3 would be minus 24. So there we have it, because then we can simplify that even more. Okay, so what are we actually doing? Each time we are multiplying, what did we do with our exponents? We actually added them together. So when you are multiplying a variable that has exponents, you can add the exponents together. Here, the same thing, a to the power of 2, a to the power of 2, you are multiplying, so you just multiply out and then you add your exponents together. Right, so it would be 8 times minus 3 minus 24, a squared times a squared, 2 plus 2 is 4. Right. Let's try this with an equation. Can get a bit more tricky with an equation, so let's go through this quite carefully. We've got 3x squared is equal to 27. So the same thing applies as when we'd worked with equations in the lesson before. We're going to do the opposite operation to make sure that our x is left on its own. So we're going to go 3x squared, we're going to divide it by 3 to make sure that x squared is left on its own. So what we do to the one side of the equation, we have to do to the other side. Remember that scale that we need to keep balanced at all times. So 3x squared divided by 3 gives us x squared. 27 divided by 3 gives me 9. But we're not finished yet because we've got an x squared and we need an x. So we're going to square root the x squared and therefore we're going to square root the 9. Again, keeping our scale balanced at all times. Right? It's going to be x squared square rooted gives me x, and the square root of 9 is 3. So my answer here is x is equal to 3. Let's substitute it in. We're going to put it in here. 3 squared is 9. 9 times 3 is 27. It works. So remember, I said to you before, if you want to check, if you're not so sure whether your answer is right, substitute it back into the original equation. Right, let's do another one. Okay, we've got 5b squared plus 27 is equal to 2b squared. There's our equation. Now, what we have to do is we have to get all our variables on the one side and all our constants on the one side. Remember, 27 is a constant because it is 27. That's what it is. There's no variables. There's nothing that can change that value. Whereas 5b squared, we want to find out what the value of that b actually is, and that is the same value as in the 2b squared. So let's work this out. We're going to try and take away that 27 on this side. So if we take away the 27 on that side, we've got to do the same to this side. So that will give me 5b squared on this side, on the left-hand side of the equation, with 2b squared on the right-hand side minus the 27. Now we should try and get our 2b squared to this side so that all our variables are on the same side. We now have, we had to minus 2b squared from this side, which means we minus the 2b squared on that side. We end up with 3b squared on this side, on the left-hand side, because 5b squared minus 2b squared, they are like terms. We can simplify those to be 3b squared. On this side, we've got 2b squared minus 27 minus 2b squared. Those cancel each other out. It ends up being 0. So we're left with 27. Actually, it should be a minus 27. Right? Let's just carry on. 3b squared divided by 3 to take that 3 away is equal to, should be minus 27 divided by 3. We would end up with b squared equaling minus 9. And then we square root the minus 9 and we square root the b. It would be b is equal to 3. It actually isn't. It would stay as being minus 9 because nothing multiplied by itself would be minus 9. So it would be minus 9 under the square root sign. Sorry about that, guys, but you can see even I can make a mistake. In fact, I make lots. Now you try this one. I want you to pause the video, try and work this out, and we will come back and look at it together. Right, let's have a look what you did. Okay, we've got minus 2a cubed plus 15 is equal to 3a cubed. We want to get our 2a cubed onto this side so that all the like terms are together. So what we would do is minus 2a cubed plus 15 plus 2a cubed is equal to 3a cubed plus 2a cubed. Can you see how I've taken that 2a cubed and I've put it across this side? So what I did to this side, I did to this side. I kept the scale balanced. Right, I end up with 15 over here because that minus 2 plus 2a cubed gives me nothing. On this side, I've got 3a cubed plus 2a cubed is going to give me 5a cubed. So I've got 15 is equal to 5a cubed. I then say 15 divided by 5 is equal to 5a cubed divided by 5. I'm going to get 3 is equal to a cubed. Now watch this. I'm going to cube root the 3 and I'm going to cube root the a to the power of 3 so that I get a on its own. So a stays on its own, but my answer is then a is the cube root of 3, which we can't really solve. Okay, and that's fine to get an answer like that. It's going to be difficult to put it back in here, but you can put it back in there because that cube would actually cancel out the cube root and it would end up being 2 to the power of, 2a. Okay, right. Well done if you got that right. Okay, let's see what we covered today because we've actually done so much. We learned how an exponent works with a variable. We learned how to expand a variable with an exponent. We learned how to work with a variable with an exponent in an expression. And we learned how to solve variables with exponents in an equation. Well done, guys. That was quite a long lesson. That was a lot to think about. There is an activity posted for you. Try and do the activity and look at the memo. And remember, if you have any questions, to email your grade 8 at WorksheetCloud.com to submit any questions and somebody will get back to you with answers. Thank you again for watching our grade 8 maths class and I'll see you again next time.